Now for the distance between a point and a plane. As with the distance from a point to a line, this means the minimal distance, and so that'll be the distance along a vector orthogonal to the plane. So suppose the plane is given to us as a point P on the plane and a normal vector to the plane. Then if we draw the vector from S to P, we see that that vector going straight down from the point to the plane equals the projection of that vector from S to the point on the plane, the projection of that vector onto the normal vector. So let's write this down. Given a plane containing a point P and a normal vector n, if we take then any point S in space, the distance from S to the plane is the length of projection onto n of the vector from S to P. And I could have taken the vector in the other direction, like from P to S, since we're taking the absolute value. And then the length of this projection we can calculate using the dot product. That will be dot product vector from S to P, dot producted with the vector, then divided by the length of the normal vector. For example, let's say we want to find the distance from the point 1, 3, 1 to the plane defined by the equation 2x minus 3y plus z is equal to 4. So from the equation of the plane, we can see that a normal vector to the plane will be 2, negative 3, 1. And then we need to produce a point on the plane. And so for that, we can just set two of the variables to be 0, so x and y, and then the remaining will tell us that z has to be equal to 4. So you could have done this with the other, either the other two variables. So you could have taken y and z to be 0, in which case x would be equal to 2, or you could have taken x and z to be 0, in which case you would have gotten y equals negative 4 over 3. So I'm going to work with 0, 0, 4, but you could have made a different choice. Okay, so now P minus Q is 1, 3, negative 3. And so then we dot that with the normal vector, divide by the magnitude of the normal vector. So that's 1, 3, negative 3, dot 2, negative 3, 1, over square root 4 plus 9 plus 1. So this will be 2 minus 9 minus 3 over root 14 equals negative 10 over root 14. Now, since we want to find the distance, take the absolute value of this, and so we get that the distance from P to the plane is 10 over root 14. Okay, now what about finding the distance between two planes which are parallel? So from the equation of these planes, we can see that both have the normal vector 1, negative 2, 3. Now I want to produce examples of points on both planes. So we can do what we did just now. So I'll set y and z equal to 0. So P equals 4, 0, 0 is on the first plane, and Q equals negative 2, 0, 0 is on the second plane. So now P minus Q dot normal vector over length of normal vector. This will be 6, 0, 0 dot 1, negative 2. Whoops. 1, negative 2, 3 over 1 plus 4 plus 9. So that'll be 6 over root 10, root 14 is the distance between the planes.